You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your PMP certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Quality in project management is often misunderstood as just testing the product at the end. In reality, quality is about building fitness for use and conformance to requirements into the process from the start. Fitness for use means the deliverable solves the user's problem or fulfills its intended purpose. Conformance to requirements means it meets agreed specifications and acceptance criteria. The principle PMI emphasizes is prevention over inspection. It is far more effective and less expensive to design processes that reduce defects than to rely on inspection to catch them later. The project manager's stance is to align standards, processes, and acceptance criteria to value delivery. On the exam, STEMs often test this when defect spikes, heavy rework, or unclear acceptance criteria appear. Prevention versus inspection is one of PMI's favorite contrasts. Prevention refers to proactive measures such as training, process reviews, or mistake-proofing steps that stop defects before they happen. Inspection, by contrast, means detecting errors after the fact running tests, audits, or final reviews. While some inspection is always necessary, projects that rely too heavily on inspection burn time and budget fixing avoidable problems. A quality plan weighted toward prevention not only produces better outcomes but also reduces risk. On the PMP exam, options that lean on inspection alone are rarely correct. The best answers emphasize building quality into processes, not testing it in later. The first step in ensuring quality is planning. The quality management plan defines the standards the project will follow, the metrics that will be measured, the methods used to assess quality, and the roles responsible for carrying them out. This includes aligning acceptance criteria, definitions of done and ready, supplier quality clauses, and the project's test strategy. Sampling and inspection approaches must also be chosen carefully, balancing cost and risk. The project manager integrates this plan with risk management and change control, ensuring that quality considerations are part of every decision. On the exam, correct answers emphasize integration, not treating quality as an isolated document. A quality plan must also define when and where checks occur. Control points moments where deliverables are measured against standards help prevent drift. For instance, holding design reviews before coding begins ensures alignment. Similarly, verifying supplier quality on receipt of goods prevents defective inputs from corrupting later work. Planning inspection frequency requires judgment. Too frequent and progress slows. Too infrequent and defects accumulate. Documenting assumptions here is vital, so if issues arise, the team can trace decisions. On the exam, look for answers that stress thoughtful integration of control points, rather than generic promises to test everything. Managing quality means putting the plan into action during execution. This is a process-oriented activity, sometimes called quality assurance. It includes preventative measures such as reviews, audits, pair programming, or peer reviews. Building quality gates into workflows ensures that deliverables cannot move forward until standards are met. Supplier quality management is another element, verifying vendors are delivering consistent quality and holding them accountable to contract terms. Training and job aids are also part of managing quality, ensuring the team understands and applies critical to quality steps consistently. On the exam, answers that emphasize proactive, process-level checks are aligned with PMI's definition of managed quality. Managing quality is not just about formal checkpoints. Culture matters. A culture of continuous improvement, where team members raise quality concerns without fear, is one of the strongest preventive measures. For example, encouraging developers to perform peer reviews before committing code can catch defects early. Encouraging team members to flag unclear requirements creates better deliverables. The project manager fosters this culture by modeling attention to detail and respect for standards. On the exam, Watch for scenarios where poor quality results from weak culture answers that emphasize training, peer review, and preventative checks are usually correct. Controlling quality, by contrast, focuses on the product itself. This is sometimes called quality control and involves verifying deliverables against acceptance criteria and standards. Techniques include logging defects, triaging them by severity, and resolving them according to agreed timelines. Traceability is a hallmark of effective quality control. Requirements must be linked to tests, and tests linked to evidence. This ensures nothing slips through the cracks and that every requirement is validated. Feedback loops connect back to the quality plan, enabling process improvements. On the exam, answers that emphasize traceability and defect resolution with evidence usually represent PMI's philosophy. Defect management is a critical part of controlling quality. Not all defects are equal. Some may be minor and acceptable within tolerance, while others threaten delivery. The triage process prioritizes fixes that have the greatest impact on value or compliance. Equally important is documenting the resolution process. If a defect is waived, stakeholders must approve it, and the rationale must be logged. This creates an audit trail and avoids disputes later. On the exam, distractors often suggest ignoring small defects or bypassing approvals. The correct answer always involves formal handling through logs and traceability. Traceability also supports compliance and stakeholder trust. A requirement that is not backed by test evidence creates risk. Stakeholders may reject deliverables if they cannot see proof of conformance. By linking requirements to acceptance tests, test results, and sign-offs, the project manager creates visible assurance that promises were met. This also strengthens the ability to defend against claims or disputes. On the exam, scenarios involving unclear acceptance criteria often point toward traceability as the best solution. PMI emphasizes that done must always be supported by evidence, not assumptions. Communicating quality is the final element in Part 1. Quality data must be presented clearly so stakeholders can interpret it. Visual tools such as Pareto charts, run charts, or control charts provide insight into patterns of defects or performance. Thresholds and triggers must be defined so stakeholders know when action is required. For example, a defect rate exceeding a certain percentage may trigger additional testing. Reporting by exception reduces noise. Instead of sending raw data constantly, the project manager highlights only where thresholds are breached. Approvals and non-conformance handling must be documented visibly. Quality communication is about context, not just numbers. Stakeholders want to know what quality metrics mean in terms of value delivery and risk. For example, defect density is trending down is more informative than "we logged 25 defects this week." Providing context turns raw measures into actionable insight. On the exam, correct answers often involve using visuals and thresholds to reduce noise and clarify meaning, not simply broadcasting data. PMI's philosophy is that communication should enable better decisions, not overwhelm stakeholders. Visuals like Pareto charts illustrate the vital few problems that cause most defects, helping stakeholders focus on where attention will matter. Control charts reveal whether a process is stable or drifting outside acceptable limits. These tools make abstract concepts visible, creating shared understanding. On the exam, scenarios may describe charts without naming them. The correct answer involves interpreting patterns, logically recognizing special cause variation versus common cause noise, rather than reacting emotionally to every fluctuation. PMI stresses interpretation over formula memorization. Reporting must also respect governance. Approvals of deliverables require formal evidence of quality checks. Non-conformances must be documented and either corrected or accepted formally. Skipping these steps undermines both compliance and trust. The project manager's role is to make sure quality evidence is available, organized, and transparent. On the exam, distractor answers that involve cutting corners to save time are usually wrong. The correct answer emphasizes keeping documentation tight and ensuring approvals follow established policy. The control chart is one of the most practical tools for monitoring quality in a project. It plots measurements of a process over time against a central reference line. That center line represents the process average or expected performance. Above and below this average are upper and lower control limits, usually set at about 3 standard deviations. The key principle is to distinguish common cause variation from special cause variation. Common cause variation is normal background noise. Special cause variation signals that something unusual has occurred. The exam expects you to know that not every data point outside the average demands action, only those breaking the rules of control. Interpreting a control chart involves more than spotting outliers. For example, if 7 consecutive points fall on the same side of the average line, even if within limits, that is a likely signal of a special cause. Similarly, a trend of 6 or more points moving steadily upward or downward may indicate the process is drifting. These rules prevent overreaction to single random points while also ensuring slow deterioration is caught early. On the exam, distractor answers often involve panicking over normal fluctuations. The correct response is to interpret patterns calmly and act only when variation signals real process change. Control charts reinforce PMI's preference for prevention over firefighting. If a process is stable, action should not be taken simply to look busy. If it shows a special cause pattern, then analysis and corrective action are justified. For example, if defect rates suddenly spike after a new vendor is introduced, that is a special cause and deserves root cause investigation. On the exam, PMI expects candidates to recommend investigating the process, not disciplining individuals or hiding results. Charts point to where prevention and improvement matter most. Pareto charts complement control charts by highlighting the vital few issues that cause most defects. Named after the economist Vilfredo Pareto, the principle suggests that roughly 80% of problems often come from 20% of causes. A Pareto chart lists defect categories on the x-axis and their frequency or impact as bars. The categories are ordered from most frequent to least frequent. This allows project managers to focus energy where it will have the greatest effect. For example, if one defect type accounts for half of all rework, fixing its root cause will dramatically improve outcomes. Interpreting a Pareto chart requires discipline. The temptation is to scatter resources across every defect category. PMI emphasizes focusing first on the few categories that drive most issues. After corrective actions are taken, the chart should be refreshed to see if improvements actually reduce the top problems. This creates a feedback loop. The exam often presents scenarios where the correct action is to run a Pareto analysis before acting, not to simply add more testers or fix random defects. Pareto thinking ensures prevention is targeted, efficient, and measurable. Together, control charts and Pareto charts provide a simple but powerful toolkit. Control charts reveal whether processes are stable and in control. Pareto charts show where to direct improvement efforts. They work hand in hand. First, detect whether variation signals a problem, then identify which categories of defects are most worth addressing. On the exam, correct answers emphasize interpretation and prioritization. Distractors often involve either overreacting to noise or spreading effort thinly across all problems. PMI's philosophy is to act on evidence, target causes, and verify improvements. Quality practices differ between agile and predictive environments, but the principle of building quality in remains universal. In Agile, frequent increments and automated tests act as built-in quality gates. Definitions of done and definitions of ready make quality expectations explicit. Testing is embedded into each sprint, reducing the risk of large defect accumulations. Predictive projects rely more heavily on planned inspections, stage gate reviews, and formal quality milestones. Both models require evidence. The exam expects candidates to align practices to context. automated testing for agile, formal sign-offs for predictive, and hybrids that combine the two. Consider a scenario. A project team faces tight deadlines, and stakeholders push for speed. Defect reports show that one defect type A occurs far more frequently than others. Options include adding more testers, fixing defects at random, running a Pareto analysis and addressing the top cause with a preventative change, or re-baselining the schedule. The best next action is to perform a Pareto analysis, confirm that type A is the dominant issue, then implement a preventative fix targeting that cause. Afterward, measure whether the change reduced overall defect rates. On the exam, this structured approach usually represents PMI's intended answer. In a regulated environment, the same scenario adds another dimension. After running the Pareto analysis and implementing preventive fixes, the project manager must also document the corrective actions, obtain stakeholder sign-offs, and ensure the evidence is archived for audit purposes. Compliance does not change the principle, it simply adds rigor to documentation. The exam may present this variation, and the correct answer will always involve both preventative action and proper documentation, not speed at the expense of compliance. Exam pitfalls around quality are predictable. One is treating every fluctuation in data as a crisis, failing to distinguish between common and special cause variation. Another is relying exclusively on inspection without preventive measures. A third is skipping traceability, meaning deliverables are declared complete without evidence linking them back to requirements. Finally, re-baselining the project in response to quality problems without root cause analysis is a common trap. PMI expects candidates to analyze and correct causes, not simply shift baselines to hide problems. Overreacting to noise wastes resources and demoralizes teams. If a process is stable and variation is within control limits, then occasional spikes are expected. Taking unnecessary corrective actions introduces new risks and slows delivery. On the exam, distractors often describe panicked responses to normal variation. The correct answer emphasizes calm interpretation and patience until a true special cause is identified. This is why PMI stresses that control charts are tools of interpretation, not instruments of micromanagement. The inspection-only mindset is another trap. Projects that test in quality rather than build it in inevitably experience higher rework, delays, and cost overruns. On the exam, answers that describe inspection as the sole or primary quality strategy are almost always incorrect. The better answers emphasize prevention, cultural reinforcement, and continuous feedback. Traceability gaps are equally dangerous. Without linking requirements, tests, and evidence, teams cannot prove that quality promises were fulfilled. Exam questions often highlight stakeholder rejection of deliverables. The correct answer is to strengthen traceability, not to push the product harder. A quick playbook for quality can help anchor your approach. First, plan by defining standards and acceptance criteria, aligning them with value. Second, manage quality by embedding preventative measures reviews, audits, training, and supplier controls into workflows. Third, control quality by verifying deliverables against standards, logging defects, and ensuring traceability. Fourth, use charts wisely. Control charts to detect process stability. Pareto charts to target the vital few causes. Fifth, communicate quality clearly with visuals and thresholds, preserving evidence and approvals. On the exam, answers that follow this playbook align with PMI's philosophy of prevention, interpretation, and disciplined documentation. In conclusion, planning and managing quality is about embedding assurance into both processes and products. Prevention is prioritized over inspection, traceability ensures evidence of conformance, and visuals such as control and Pareto charts guide interpretation and prioritization. Agile, predictive, and hybrid environments all require discipline, adapted to context. Exam pitfalls typically involve panic over noise, inspection-only mindsets, skipped evidence, or casual re-baselining. The correct answers consistently emphasize calm interpretation, preventive action, traceability, and communication. This reflects PMI's broader philosophy. Quality is not a checkpoint at the end, but a continuous commitment to value and compliance throughout delivery. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.